Hello. Today I will be going over my experimentation and results for Physics 2211 Lab 5 on breaking the speed of sound. So this experiment aims to model the world record freefall skydive by Felix Baumgartner. The free fall will be modeled in Python and will model the freefall based on physical principles and real data from the jump, including height, time, and the mass of Felix combined with his suit. This experiment ultimately aims to determine if Felix broke the speed of the sound during his freefall, which was his ultimate goal. So this experiment looks at multiple physical principles, including velocity and position updates, net force, drag force, and gravitational force. Here we have the formula for the force of gravity on Earth using the mass of the object and g, which is 9.81 meters per second squared. The position update formula is here, and this is how we will update the position of Felix in our program. This is drag, which we will calculate iteratively. Here we have the velocity update formula, and then this is the velocity update with acceleration expanded to show net force and mass. So the initial conditions of our experiment, so the mass of the weight was 143.03 kilograms. And this was determined by combining Felix's weight of 161 pounds, which when converted to the SI unit of kilograms is 73.03, and the weight of the suit he wore, which was 70 kilograms. The initial time was 0, and initial velocity was 0. The initial position was 0, 38,969.4 meters, 0 meters, and this was found from his jump height, which was 38,969.4 meters above Roswell, New Mexico. And so the amount of times that the program will iterate is 228 seconds, and that is the time it took for Felix to reach max velocity. And then the speed of sound is 343 meters per second. Gravitational force is negative 9.81 or 9.81 meters per second squared. So here we have the code. So this is the mass that we had just discussed. This is the position and velocity, which will be updated constantly in the program. Here we have the time at 0, and then delta t, which was set to this because it was the video of his skydive was recorded on a 30 frames per second camera. Here we have g and then j hat, which is the directional vector that we will use to calculate drag. Here's b, which is the value that we'll use to calculate drag, and this had to be found through trial and error. So here's the loop for calculating over the 228 seconds. We will calculate fnet, and we will update the velocity and positions. And then we will advance the clock here, and then after this, and we will print the position each step through, and then once the entire loop is finished, we'll print the ball's velocity at the end, or Felix's velocity. So here are the results. The final velocity was 394.6 meters per second, which is faster than the speed of sound, meaning that in this program, Felix did successfully break the speed of sound. Here we can see the graph of the forces, with the blue being drag and orange being gravitation, and they are exactly equal, which is what occurs during terminal velocity. Here we have position and time, just shows the decrease, and then velocity versus time, which follows a almost negative logarithmic curve as it